room is ready. I'm the only one that I.
You want to use this white box, you can change the camera onto this one.
It's okay to stay here.
Okay.
I don't hear you, Antonio. I don't hear anything. It's a problem from here or from Antonio.
Sit here. You can listen that the room is already clear. We can begin. We can listen.
Can start.
I think so. You can turn on the mic. So the mute.
No, it's turn on.
Okay. Right, turn on.
But I don't know that they hear me.
Share screen.
Okay. It's okay.
No, use. I think you need to share screen again because it stopped. Yeah.
Just a second. Entire screen. Screen one. Screen two now. It's good enough, no?
It's good.
But I don't see my presentation on this level. Just a second.
Can you hear me now?
Yeah, Antonio, now I hear you.
Okay, thank you. So sorry for this small delay. I think if it's everything okay in presence, we can start with this session. Everything is okay? Can you confirm me? Okay. So, hello everyone. This is the first session of X 2026 conference about the workshop, the contribution in the workshop Elliot. So the workshop is about urban mobility and last mile logistics. This is the first session. The second one with other contribution will be tomorrow. I want to thank you for everyone who contributed to this interesting and timely workshop. Now I want to introduce the first contribution. The first contribution is titled Evaluating the Impact of Traffic Control System Failures on Intersection Level of Service Using Microsimulation. The authors are Denis Codroiu, Eugen Rosca, Aura Rusca, Maja Skuric, Joanna Dinu, Valentina Radu, and Arman Stere. And the paper is presented by Dr. Denis Codroiu of National University of Science and Technology of Bucharest. So I want to let the word to. Sorry, I think the audio is a bit disturbed. I want to let the first presentation begin. So thank you, Denis. The floor is yours.
Thank you, Antonio. So you can see my presentation?
Yes, we can see the presentation.
Thank you. First of all, I'm Denis Codroiu. I'm from Polytechnical University of Bucharest, and today I will present the article evaluating the impact of traffic control system failures on intersection level of service using microsimulation. Okay, let me start with what this matter. Signalizing protection, like we all know, are some of the most important points of the city's road network. The traffic light decide who is go and who is wait, and we help to keep both safety and moving. We ensure we measure how well an intersection works using something called level of service or LOS, which is a grade from A to F, which means basically how long time drivers wait at the stop sign. The problem is that the system can fail, a detector or controller, or the power can go down, and when this happens, the intersection doesn't work properly anymore. Okay, before our work, let me quick show you what the research stands. Traffic flow modeling has come a long way, starting.
Sorry, Dr. Codroiu, we are seeing the double screen of the presentation, not only the single one. We are seeing both this slide and the next one.
Okay, I don't know what happens. So,
and we have you.
You can help me.
Yeah. And what can I change? Yeah, but I need to show again.
Yeah. See what?
Yeah. And
now.
Yes, yeah.
Okay.
It's not. Oh, yeah.
Okay, perfect.
Yeah.
Okay. Okay. So the simulation model starts with cinematic wave theory in 50s, and after that, the model grew up with individual traffic modeling. And after that, in these days, we have smart data collection and digital twins. We can see on the graphic that was an accelerated growth after the 2050s. So, what the field has established, we have a simulation tool like PTPVSIM, who help us to model vehicle flowing. We have digital twin to help us to recreate real-time modeling, and we have many validate methods for simulation. But the gap is that we don't have an explicit model for traffic control system failures. So we can measure the loss degradation, how it works. Okay, motivation. We see that in real world, the traffic control system works well when we have lights, but it's sometimes when these lights don't go properly. So we have a defection in terms of traffic control system. What we want to do is to measure how this failure can be measured to improve the maintenance of the intersection. The goal is to quantify how much traffic system failure degrade intersection level of service, of course using a calibrated PTV-VZ micro-simulation model. We reproduce a real intersection from Bucharest in PTV-VZ. We measure the operational impact on more parameters such delay or queue and loss per approach at that intersection. And after that, we can support an evidence-based traffic control system maintenance strategy. We start from the research problem. How much do traffic control failures degrade intersection level of service? This is the main question, and we have a lot of small questions, like which approach suffer most, because we don't look at the intersection, just the whole picture. We want to go deep and by each approach. And what scenario is the worst, failure or winter scenario? So to put together, we have the gap. So our objective is to build a VZ model based on intersection from Bucharest to test different scenario of failures and to compare after that with normal scenario. And with this comparison to quantify lost impact. Here we have the methodology. We have like inputs the data collection from inductive loops. We have traffic demands for each approach, each movement, and we have, of course, a signal plan for the normal scenario. After that, we put this in the PTV-VZ model, and we change some parameters from Wiedemann 99 approach. We have different scenario. We study in this paper 3 scenario, a normal one, a flashing yellow, and a winter scenario. And after that, we can manage to see the performance according to the HTML level of service indicators. Like I said before, we have 3 scenarios. First one is normal operation, when the traffic lights go properly. We have the second scenario when we have flashing yellow, so the traffic based on right of way rules. And the third scenario was the winter scenario when you adjust the behavior parameters such as acceleration, deceleration, medium speed, and so on. Okay, the case study is a real intersection from Bucharest in District 6, Iuliu Boulevard with Virtuții Road and Lujerului Street. Is a 4-approach intersection with multi-line signalized intersection. In the back, we have 6 signal program, and for east to west, we have longer green because the Iuliu Boulevard is the main exit from the Bucharest to the town. Okay, from data collection and detector placement, we used inductive loops at entry and the exit of each approach. By each approach and by each direction, from every access, we can go straight, turn left or turn right. For data collection, we cover 1 week in February, 24 hours per day, but for this simulation, we use just the data from 9 February, when was typically urban condition, no rain, no holidays, no nothing. And we can observe that the peak hour was in the morning between 7 and 8 when the volume of traffic was high. We have 12 movements, like I said, because from every axis we can go straight, right, or left. Simulation data. input data. From the inductive loops, we can see how the traffic works. You can see that the Boulevard Ulimanu from east, we have a total of 2,200 vehicles per hour, and the main direction is straight from the east to west. So we need to judge the performance. So we extract 5 indicators that can be evaluated across our scenario. We have average delay, queue length, number of stops, traffic time, and after that, the level of service. So the results. We analyze that 5 parameters. So from maximum travel time was made by each approach that we can see from scenario to scenario 2. We can see a decrease of the maximum travel time for D01 and D02 because it's the main road of the intersection and they have priority. But the D05 and D06, that is a secondary road, and they need to stop to let the priority rules goes. We can see an increase up to 60 times degradation. For average delay, it's almost the same story. We can see that the for Boulevard Ulimanu, we don't have almost no average delay on D01 and D02, but the secondary, when we have D06 and for the D10, we can see an increase of average delay. In the winter, it is not quite different from the normal scenario. The same pattern we can see also on average queue length. Average queue length was made, the indicator was extracted by access. We can see that Ulimanu from east has almost no queue length, but on the X2TA, that is a secondary access, we can see an increasing also in scenario 2 and scenario 3. Okay, so we have delay, so we can discuss about level of service. If you look overall of the intersection, we can see that the level of service remain E across all the scenario. But if you go deep, we can see that in scenario 2, we have some improvement from Boulevard Ulimanu, so from D01 and D02, that turn from E to A, but the otherwise all the direction remains F, the secondary. So we can discuss according to HMM methodology that loss mask imbalance. We don't look so many people don't look at the deep picture. They just look at the level of the intersection. If you look at the level of intersection, we can see that overall loss stay E in our scenario, but we need to approach level analysis that is essential to understand exactly what happens in that intersection. About winter and failures, winter degradation is uniform and predictable, but control failures is far more destructive. Some key takeaways. Traffic control system failures hit secondary direction hardest, as we can see in the parameters. So the impact is far from uniform. Flashing arrow helps priority flows, but collapse flows. And we can see that microsimulation works and is very effective for quantifying failure impact at the component level. Where will this go next? We want to test adaptive and resilience control, but to introduce also human in the loop. In Bucharest, almost all of the time, but priority in the morning and in the night, the peak hour, there is a police officer in the intersection, so we want to test how this can improve or these don't improve the performance of the intersection. And also to implement the connected vehicles and the real-time data from them. Thank you. That was me. It was my first presentation, so sorry for the I don't know, emotions. Thank you.
Thank you, Dr. Cocroio. Thank you. So I want to ask, there are any questions for this presentation for the relator from home or from the audience in presence? I cannot see I cannot see eventually if there is someone from the Portugal who is attending in presence, if there are questions. So eventually you can report it to me. So, okay. There are any questions from the audience? Okay. I think there are no questions for the audience. So thank you, Dr. Codrogo. Good luck for for the successive presentations of your career. And we can move to the next presentation. The next presentation, the paper title is an exploratory analysis of injury severities in crashes involving vulnerable road users, evidence from Thessaloniki, Greece. The authors are Stavros Kodorinis, Athanasios Demiris, Grigorios Fondas, and Socrates Basbas, all of them from Aristotle University of Thessaloniki. Presenter is Professor Grigorios Fondas from University of Thessaloniki. So, Grigorios, thank you. The floor is yours.
Thank you, Antonio. Let me try to share my screen. Okay. Okay, entire screen. Okay, the window. What you can see at the moment, nothing.
We are seeing the first slide, but with all the okay.
Now you can see the full screen.
The full screen, yes.
Not the notes and the double screen.
No, all the full screen.
Excellent. So thank you very much, Antonio, for the very nice introduction. Thank you, everybody. Let me check the time so I will not waste. I will not spend more from the allocated time. I'm Greg Fundas, exactly. This is an outcome of a joint work with Stavros Athanasios and from Aristotle University of Thessaloniki, our students, and of course, Professor Socrates Basbas from the same university. And today we will discuss about something interesting, always classic, and always classic also, which is about road safety for vulnerable road users. As we all know, road safety is a major and persists to remain a major public health issue across the globe, even in developed countries, despite all the tremendous improvements we have seen in the previous decades and over the last few years in terms of infrastructure, in terms of technologies, in terms of policies. And in the heart of this major public health issue, especially in developed countries like Europe, we have the vulnerable road users. And as you all know, vulnerable road users mainly consist of pedestrians and cyclists. And why they are vulnerable? Because they do not have virtually any physical protection against it, especially the motorized road users. So in case of a collision or any other hazardous incident, the vulnerable users actually dissipate all the kinetic energy that is released during a crash, and of course they are more likely to get seriously injured. So in Europe, and this is the reason I mentioned before about developed countries, the public health aspect of road safety particularly concerns the vulnerable road users, given that they account for approximately half of the casualties that we see on our roads, even today. Right. So research about VRUs, vulnerable road users, is more imminent than ever, is more urgent than ever. Especially perhaps we need more, let's say, disaggregate findings, more disaggregate evidence that can perhaps integrate insights from different cities and from different case studies where the mixed traffic environment and also the urban planning context perhaps pose different and more, let's say, counterintuitive or counteracting pressures on the safety of vulnerable users. And this is exactly the scope of our study today. So I don't want to spend much time on the literature review in the sense that the road safety, especially for vulnerable road users, is something that has been studied over the last few years. As we have seen, for example, for injury severity studies, that several demographic, behavioral, vehicle, and infrastructure-related factors are likely to, let's say, enhance the severity of crashes, especially for VRUs. However, what we have seen, and this is actually the main motivation of our study, is that the findings about the determinants of VRU safety are not homogeneous. There are significant disparities across cities and countries, especially in Europe. And this is where the element of country-specific variations or city form perhaps may play an important role. This is even more imminent for Greece, where we have very limited evidence over the last few years about, let's say, the road safety performance of pedestrians and cyclists, and even more imminent for Mediterranean cities, where they have this mix of mixed traffic environment, quite diverse landscape, and also, let's say, a bit unique characteristics in terms of segregated infrastructure for VRUs. So, long story short, the goal of our research is to identify the determinants of pedestrian and cyclist injuries separately in a quite typical Mediterranean city like this of Thessaloniki, where the key, let's say, factors, the key contributing factors of road safety for VRUs remain unexplored. And I will explain in a while, in a nutshell, why Thessaloniki is a very, very specific case study for this work. As you will see also in the map, I'm not really sure how much you can identify that, but Thessaloniki is a typical Mediterranean city that is developed across the coastline, has a great seafront, so you're more than welcome to come if you are not haven't here so far today. And it has a very diverse landscape also, consisting of, let's say, hilly, flat, and mountainous terrain in a very, very, let's say, dense urban environment. We have significant presence of motorized vehicles, but on the same time, this significant share of motorized vehicles is interacting excessively with a strong presence of VRUs, especially pedestrians and cyclists. So this environment, which is quite, let's say, challenging in terms of all the pressures that we see on road safety, is particularly exciting for studying the determinants of road safety for VRUs. We used crash data from the Hellenic Statistical Authority, the Elstat, from a time period between 2019 and 2021, which is also a particularly interesting period. It's, of course, it includes the COVID-related effects in terms of mobility restrictions, but on the other side, it's a period where we saw a surge in, let's say, use of active travel, especially walking and cycling, because of the restrictions to the motorized vehicles. In this context, during that 3-year period, we identified approximately 906 crashes, including VRUs. The majority of them included pedestrians, and only a specific part of these crashes, 142, involved cyclists, which is seemingly good news in the sense that we don't have so many fatalities for VRUs. But in fact, they are not good news because, as we all know, there is a significant level of underreporting in VRU crashes, which can induce significant bias in statistical modeling. So in terms of quantitative statistical analysis, we started with some, let's say, non-parametric statistical associations, which provided some very wide results. But in order to provide more accurate and more powerful estimates, we estimated binary logistic regression models with using backward likelihood ratio procedure for variable selection in the model. In fact, our dependent variable was injury severity, and it was binary. Actually, it was framed to be binary, with 0 reflecting a slight injury, which, as expected, slight injuries account for the vast majority, more than 93 or 95% of observations for both types of crashes, and 1 reflecting the serious or fatal injury, which accounts for 6.5% for pedestrians, 5% for cyclists, quite alarming proportions compared, for example, to the respective proportions of serious or fatal crashes for motorized vehicle users. And I will not spend more time on the methodological aspect. I will go directly into the results, starting from the most, let's say, enriched model, the one about pedestrian-involved crashes. I will start directly with the socio-demographic characteristics. We saw that females are less likely to increase the severity of injuries, are more likely to sustain slight injuries, as you will see here with the negative sign, whereas elderly pedestrians, those aged 61 or above years of age, are more likely to sustain severe, serious, or fatal injuries, which is an anticipated result considering also the physical vulnerability of this group of users, right? Going directly to the road geometry, we saw that roads with a width between 5 and 7 meters, which actually account for the majority of roads in the city of Thessaloniki, are also associated with higher likelihood of injury severities, which also may reflect the typical higher speeds that are observed in these kinds of roads, and along with the poor visibility conditions that we have seen in these types of roads, because Thessaloniki is a highly congested city, and in these types of roads there is significantly on-street parking, which can act as a barrier for visibility conditions. Moving to the driving behavioral characteristics, vehicle maneuver, traffic violation, and speed limit violations were found to increase the likelihood of severe injuries, particularly traffic violations of traffic lights, particularly or stop signs, were found to be the most pronounced, to have the most pronounced effect on injury severities, as well as the violation of speed limit, which show that unsafe driving behavior are directly associated with very, very severe outcomes. Regular pedestrian position, in other words, in cases where we had crashes where pedestrians moved through the designated crossings or through the designated trajectories, we saw that these cases were associated with lower likelihood of injury severity, whereas traffic composition was also found to affect injury severities, with higher proportions of heavy vehicles also increasing the likelihood of severe injuries. Again, when a heavy vehicle is involved, probably the kinetic energy that is involved in the crash is very high, and of course this is absorbed, unfortunately, by the vulnerable road user. Going now to the results of the cyclist-involved crashes, as you will see here, the results are quite more parsimonious, and this is expected, considering that our sample was quite small, approximately a bit less than 200 observations. However, the results here are quite consistent with the results we saw in the pedestrian model, in the sense that road width between 5 and 7 meters and traffic violations were consistently found to increase the likelihood of severe injuries. In other words, crashes that involved bicyclists and occurred on roads with a width between 5 and 7 meters, or crashes where we identified a violation of the traffic light of the stop sign, are more likely to result in serious or fatal injuries. Overall, as we saw that the three main factors in these results, we saw that the three main factors of road safety, in other words, human factor, vehicle factor, and infrastructure, were altogether identified as significant determinants of higher injury severities for VRUs. However, the most pronounced impacts, and this is a very interesting result, was consistent in both models, and the most pronounced impacts actually were drawn from the unsafe driving behavior. In other words, violations associated with traffic monitoring or with speed selection were the strongest predictors of serious and fatal injuries involving VRUs. This is a quite alarming finding that should perhaps alert all the more policymakers, especially in terms of traffic control measures that they need to take. And the other important finding that was also consistent between the two models was the road characteristics of Thessaloniki, which were found that the road type, the road width particularly, was found to have a strong influence on injury severity in both cases. So just in a nutshell, and before we conclude, all the kind of results that we saw are quite in line with what we call Visual Zero and Safe System approach, which has been lately also adopted by the Greek National Policy of Road Safety. So these results show that driving behavior and pedestrian behavior is particularly critical. So we need an enhancement in terms of pedestrian and cycling infrastructure. This is at least what is suggested by the results. We need also to prioritize safety countermeasures, particularly on corridors and arterials, especially in dense urban environments with high VRU exposure. And of course, this study perhaps provides some preliminary insights, some, let's say, indicative associations. Future work perhaps could leverage more large data sets from more cities that perhaps they don't have only the unique mobility characteristics of Thessaloniki. And of course, the analysis could be enhanced using more perhaps advanced econometric and statistical approaches that take account also for unobserved heterogeneity. So the findings will be more reliable and the policy measures then can be quite more accurate. I will not spend most of the time. I think that we discussed the key elements and the key nuances of that research. And of course, I would be very happy to take any of the questions that you may have. Thank you very much.
Thank you, Professor Fundas. So, there are any questions from mom or from who is in presence for Gregorios Fundas? No questions. Gregorios, no, I don't have a questions, okay? I have more just a curiosity, considering my short frequentation of the city of Thessaloniki, and considering that in order to do this work, you saw the data for all the city. My curiosity is only this, and it is more about the data set. Usually with the Professor Basbas, which I greet, I know that is just connected, we know that Thessaloniki has the shape of a butterfly, okay, more or less is a butterfly, which I essentially I know mainly only the eastern part of the city and not so much the western part.
Right.
So I wanted to ask, which is there is a side of the city which is more involved in road accidents compared to other ones, or there is an homogeneous distribution? Thank you.
That's a great question. Thank you very much, Antonio. And of course, your question shows that you have an internal knowledge, right, about the Thessaloniki system, especially the urban form and the mobility system of Thessaloniki. So, given that this study is focused on their use, right, and so more or less all the crashes that we observed in the data are outcomes of conflicts between motorized road users and pedestrians or cyclists. And these kind of conflicts interactions are typically observed in the city center and in the more urban dense center. So in this context, most of the crashes were identified in the historical city center or in the very, let's say, urban suburbs or urban areas that surround, let's say, the historical city center. So unfortunately, and this is a limitation of the data, of the official database, we do not have specific coordinates for each of the crash. I mean, geographical coordinates. We have, let's say, a textual description about the specific location of each crash, but we don't have the geographical coordinates. But based on the analysis of these textual descriptions of the crash locations, yes, we saw that the vast majority of pedestrian involved and cyclist involved crashes were located in the dense urban areas. We didn't see so many crash observations, let's say, in the outskirts of the city, where the vast majority of traffic there is from motorized users. However, there are some, let's say, a bit of scars and a bit of individual isolated observations there, but these were mostly associated with speed violations, right? Because in the outskirts, we have seen quite higher speeds compared to the city center. So it was not so much about, let's say, hazardous interaction between pedestrians and cyclists, but because of higher speeds that we saw in the outskirts, because most of the roads there are corridors, are arterials, the speed limits are higher. Now we have also a lower speed limit of 30 kilometers per hour. So in the city center for entire Greece. So in the outskirts, we see more only speed-related crashes.
Thank you for the answers, Professor Gregorios Fundas. Now I want to thank you and for your presentation, for your answers, for your contributions. And if there are no any other questions from home or from presence, we can move to the third presentation of this session. The third presentation of this session, the title of the third presentation is Who Owns the Space? A Near Accident Perception of E-Scooters Riders in Interaction with Pedestrians. And the authors of this contribution are Argyrios Kallisperatos, Paraskevas Nicolaou, Andreas Nikiforiadis, Gregorios Fondas, Tiziana Campisi, and Socrates Basbas. The paper is presented by Paraskevas Nicolaou of Cyprus University of Technology. So I want to thank you for this contribution, Dr. Nicolau, and the floor is yours.
Can you hear me right now?
Yes, we are hearing you.
Okay, sorry, I was muted before. So thank you for the introduction, Antonio. And can you see my screen right now, the presentation?
Yes, we are seeing the full screen of the first slide.
Okay, perfect. So again, thank you, Antonio, for the introduction. In my part, I will present the work that has been conducted from Argyrios Kalisperados, Andreas Nikiforiadis, Grigorios Fundas, Tiziana Kapisi, and Socrates Baspas, and myself, Paraskevas Nikolaou, which has the title Who Owns the Space? A Near Accident Perception of E-Scooter Riders in Interaction with Pedestrians. So the presentation will actually start with an introduction, then I will present you the problem statement, the scope of the study, the data that were collected for implementing the problem that was identified for the study, the methodology that was actually has been developed, the results, and the conclusions. So, as we all know, e-scooters were introduced in our lives several years before. And from then, we are actually frustrating on finding the rules, on finding the legislations in order to see how the e-scooter travelers can be adjusted in the environment of other commuters. So also we can observe that e-scooter drivers and e-scooters in general as a mode is rapidly transforming the way we are planning our cities, especially in terms of micromobility and urban mobility, etc. So the other thing is that shared spaces create frequent riders of e-scooters and pedestrians interactions, which raises some concerns about road safety. And as we all faced from e-scooter drivers, there are many and numerous violations conducted from e-scooter drivers, which raises again the speculation that there is not a clear legislation, or this legislation is not transparently, let's say, brought to the commuters of scooter drivers. Therefore, riders and pedestrians often fail to adapt to each other's behavior, and we actually observe near collision events or even accidents involving the two commuters. So this study investigates the behavioral interactions using observations at the field of near collision incidents. And based on that, we actually raised the problem statement of this study, which is that despite the growing adoption of e-scooters, there is a limitation of understanding how e-scooter drivers and pedestrians behave when they have an interaction between of them, the two commuters, during near collision events, and which behavioral patterns lead to higher collision risk. So the question that we tried to answer through this study is which behavioral factors increase the likelihood of dangerous interactions between scooter riders and pedestrians. Therefore, in order to achieve that, we actually set three targets. The first one was to analyze how riders adjust their speed when they are actually encountering with pedestrians. The second one is to identify the behavioral personas of e-scooter riders and pedestrians. And the third one is the estimation of which combinations of personas we identified of e-scooter riders and pedestrians produce the higher possibility of a collision. So the study area was again Thessaloniki, specifically in Kalamaria area, where actually we had two locations, one at the north side and another one on the south side of a pedestrian street in Calamaria, where we recorded 100 near collision cases, with which actually had an involvement of e-scooter riders and pedestrians. Specifically from the data collection, we created a database that included the following variables that I will actually shortly describe. The first one is the action. We actually recorded if there was an action from e-scooter drivers to avoid a possible collision with pedestrians, where we saw that 91% of the e-scooter drivers made an action in order to avoid that. In contrast with the pedestrians, which showed that the 15% of them, where they identified there is a possibility of collision with an e-scooter driver, 15% of them tried to avoid them. Awareness from e-scooters and pedestrians was if they were aware of the other commuters in order to avoid in case of a possible collision. We also record the different categories of possible collision that will be between e-scooter riders and pedestrians, where we had rear side, very close collision, a very close distance in between, so a close collision, stop and walk, corner meeting, school student incidents, and other cases. Also, we recorded the speed before the close collision incident and the speed after, identifying either the pedestrian in order for the e-scooter driver to see if they decelerate or if they accelerate, or even if they had no reaction when they were noticing a pedestrian, if the incident was recorded in a cycle path or not, if the rider was wearing a helmet, the margins of avoidance from e-scooters and pedestrians, and the pedestrian density. So based on the data collected, we actually created a methodological framework that will be able to achieve the targets that we have set for this study. So the first method that was able to identify the factors that affect the rider speed adjustment was the ordinary logistic regression, where we had in the dependent variable 3 cases: the acceleration, where the e-scooter rider was accelerated when they were noticing the pedestrians, no reaction, no difference on the speed; deceleration, when the e-scooter riders decelerate when they see a pedestrian. Based on that, we continued the second actually method that we implemented, the first logistic regression, where this approach is particularly suitable for binary outcome models, where we had a conventional maximum likelihood estimation, which may produce based on stable estimates like the estimates that, like the records that we had collected. So that's why we implemented this specific method, which was able to identify the behavioral personas which are associated with high-risk conflicts. So the dependent variable was a binary variable, where we had 1 in cases of high-risk incidents and 0 in low or moderate risk incidents. And the high-risk incidents were actually identified as the cases where the e-scooter riders accelerate upon detecting a pedestrian, while the pedestrian does not undertake any avoidance action. So from the results from the first implementation of ordinary logistic regression was that the statistically significant variables were only interaction category and pedestrian density, where interaction conflicts, which had the cases of stop and walk and corner meeting, were more likely to trigger strong deceleration of the scooter riders than passing encounters, which had the cases of rear side or very close. Just to clarify this, so for the cases when the e-scooter driver was able to see the pedestrian and stop and start walking, or if there was a corner meeting between the e-scooter driver and the pedestrian, then they were able to decelerate instead of accelerating. And also passing conflicts appeared to reduce the probability of a strong braking reaction by approximately 85%. The second one variable, the pedestrian density, was appeared that when we had low pedestrian density, for example, level of service A to B, riders, e-scooter drivers were more likely to accelerate, whereas higher densities encourage more cautious behavior, which is also logical. So after seeing which factors affecting the way that e-scooters drivers are driving, we are noticing a pedestrian, either, as I mentioned, accelerating, decelerating, or no reaction. Then we moved to the second approach, where it was to identify different personas of e-scooter drivers or pedestrians. So what we did, we actually took the database as I presented it before, and we saw which personas can be actually obtained from this database for the e-scooter drivers, which we had the aggressive e-scooter riders, where the e-scooter riders accelerated when they were noticing a pedestrian, and they were not conducting any evasive maneuver for avoiding the pedestrian. Inattentive were e-scooter riders that decelerate when noticing the pedestrian and are unaware, but are unaware, not aware of pedestrians, and do not wear a helmet. Cautious is when the e-scooter riders are not aware of pedestrians while riding and are proceeding with avoiding actions and decelerations. Once they notice a pedestrian, also wear a helmet. Responsive when riders are aware of for pedestrians and decelerate when noticing one but not wear a helmet. And risky e-scooter riders, that actually it's the riders that either accelerate or do not change their speed when noticing a pedestrian but are proceeding with an avoidance action. Also, as I mentioned, we identified the personas of pedestrians, where we had 3 personas. Attentive pedestrians that are aware of e-scooter drivers and proceed to avoid actions when noticing one. Unresponsive when pedestrians that are aware of e-scooters but do not proceed to avoid actions when noticing one. And inattentive when pedestrians that are fully unaware and do not proceed to avoid actions when noticing an e-scooter rider. So having these personas, then we proceeded how and which combinations of which actually persona of e-scooter riders and pedestrians creating the 3 levels of risk. The low risk, where e-scooter riders decelerate upon depending a pedestrian in their trajectory, and the pedestrians actively perform an avoidance maneuver. The moderate risk, when e-scooter riders maintain their speed despite detecting a pedestrian, while the pedestrian initiates and avoidance actions. And high risk, when e-scooter riders accelerate upon detecting a pedestrian and the pedestrian does not take any avoidance actions. So we found from the first logistic regression model that the aggressive riders, of course, as expected, were significantly more likely to be involved in high-risk conflicts than cautious riders. Risky riders also showed a significant higher probability of high-risk interactions. Inattentive and unresponsive pedestrians show also a significant effect on the creation of high-risk interactions between e-scooter riders and pedestrians. So having all this information, the next was to see, besides the different personas of e-scooter riders and pedestrians, to see which combinations of these personas can actually increase the risk, as mentioned before. So if we observe aggressive riders and inattentive pedestrians, and also aggressive riders and unresponsive pedestrians, we see that we have the maximum risk, which is 100% of high risk case that might lead to it, and it's also highly possible to lead to even a collision and an accident. And a lower percentage of high risk is when we have combinations of risky riders and unresponsive pedestrians, and less risk with risky riders and inattentive pedestrians. So based on what we have conducted from the methodological framework and what we have saw from the results, we made the conclusions which show that the behavioral interactions between scooter riders and pedestrians are the primary drivers of near-risk collision. And although most riders decelerate to avoid conflicts, there are some risky behaviors that, for example, acceleration and no reaction, which still occur. Pedestrians' behavior plays a critical role, with inattentive and unresponsive pedestrians significantly increasing collision risk. Aggressive and risky riders combined with passive pedestrian behaviors create the highest risk interactions. Therefore, improving safety requires behavioral awareness, enforcement, and stronger regulation measures rather than infrastructure improvements and only. Therefore, our research and our future research steps will be on validating these findings using larger databases, additional transport modes, even surveys, or even different airborne environments that include areas of different infrastructure, pedestrians activities, and traffic conditions. Thank you very much. Hello? Yes.
Yeah, we can hear you. Probably Antonio is not.
Maybe Antonio is out now.
Yeah, probably. Let's wait a bit. Because he seems frozen, so.
It's this case that you think that you are speaking alone?
That was not the case for sure.
Okay, there is now Antonio.
Are you hearing me?
Yes?
Yes, now yes.
Okay, no, sorry, it's quite strange because I followed the entire presentation. I didn't miss a second, so probably I don't know what the problem was. So I was asking, there are any questions for Dr. Nicolaou for its interesting presentation from home or from the audience in presence? Okay. So if there are no other presentation, other questions, I want to thank Dr. Paraskevas Nicolaou for his presentation, and we can move to the fourth presentation of this session. The title of the next presentation is From Anxious Rushers to Attentive Observers, a cluster analysis of university student pedestrian profiles. The authors of this contribution are Evstatios Bouras, Grigorios Fondas, Socrates Basbas, Panagiotis Giapitsoglu, Stefanos Tsoungaris, Georgios Zois, and Erling Gishti. The paper is presented by Dr. Evstatios Bouras from Aristotle University of Thessaloniki. And I want to thank Evstatios for his contribution. Please, Dr. Evstatios Bouras, the floor is yours.
Thank you, Antonio. Hello, everyone. It's nice to be once again on this conference, and kudos for the organization. Now, I will try to share my screen. Hopefully it will work, and you will see the presentation. Just to verify if you can see the first slide.
Yes, we are seeing the first slide. Okay, now the first slide full screen.
Okay, that's good enough. So I I will speak for personas as well, but following a different approach and a different topic. Our approach had to do about the pedestrians and the students of the Aristotle University of Thessaloniki. Now, I'm using two screens. That's quite confusing for me right now, but as it works for you, it will work for me. So what we did was to collect data about the behavioral patterns of students of the Aristotle University of Thessaloniki. And we did that because, according to the official data of Greece, 70% of Greek fatalities are pedestrians. So we had to examine this phenomenon and come up with some conclusions and understand why this is happening. We had a question-based survey implemented at the city of Thessaloniki at 2 spots near the campus. And we managed to collect, in situ, of course, we managed to collect a total 605 questionnaires, 304 at the first spot and 301 at the second spot. Now, as I said, we had 2 spots. That means that we had the question-based survey implemented on 2 intersections, different but similar types of intersections. We'll talk about the difference on the following slides. Now, why we did that, beside the fact that we do have, as a country, rather high level of fatalities related to pedestrians, because to our understanding, based on the literature review that we did, many or most of the manuscripts of the papers tend to analyze the phenomenon using the approach of isolated silos. We wanted to do something beyond that, and we wanted to identify personas that are related to the behavior of these participants, in our case, the students of the Aristotle University of Thessaloniki, of AUTH, I would say that using the abbreviation. Imagine having 2 students, one holding his mobile and being careful, waiting for the red traffic light to cross the street, and the second without holding a mobile device, but being very anxious to cross the street because he's late for his class. We have at the same intersection, at the same crosswalk, at the same traffic light, 2 different students, 2 different behaviors. So, excuse me, 2 different levels of risk. And we wanted to understand why this is happening, because our survey was related, beside the fact that we had students crossing a street, on using their mobiles or being socializing at the moment, discussing with a friend. So, as I said, we implemented the question-based survey. We had a questionnaire developed. We had 6 questions, demographic content, and 14 about their behavior while crossing the road, the street, while using or not mobile devices or discussing with friends. The first cross-section was at the cross-section of Egnatia Street and the 3rd of September, with 304 questionnaires filled. This specific cross-section has a permitted phasing, which means that there are flashing yellow arrows allowing vehicles to turn right, but at the same time, we have pedestrians crossing the crosswalk on the vertical road. Based on the Greek driving code, when a driver of a vehicle sees a flashing yellow arrow, must yield and give the time to the pedestrian to cross the street. Excuse me. Now, on the second spot, on the second cross-section, this is the cross-section between the roads, the Ethnikis Aminis and Alexandros Volu. With 301 questionnaires filled, we have a protected phasing. What does that mean? It means that when the drivers of the vehicles see a red light, the pedestrians see a green light, so they can cross the street, cross the road, normally with a higher level of safety, as they perceive it and as it should be. These type of intersections have the minimum or 0 conflict points by design if a driver of a vehicle does not cross the red light. we collected the data, and then we applied the k-means clustering pipeline as input variables based on our questionnaire and the replies of the students. We used the case score, the electronic distraction, the social distraction, the signal compliance, and because we use different type of replies, like Likert scale or binary values, we had to z-score normalize all these. If we didn't do that, Likert scale would prevail on this process. Then we had to identify the optimal k value. So we used the elbow method and the silhouette analysis, and through that process, we came up with the magic number 4. And then we used the on-way ANOVA statistical test across all variables to make sure that using a sensitivity test about the two different values for clusters, 3 and 5, to make sure that these variables do reflect the key feature of each persona identified, of each cluster. So based on that, we came up with these 4 personas: the attentive observer, the lost in device waiter, the distracted law breaker, and the anxious rusher. As you can see, the attentive observer, you can see the number of participants filling or matching this persona, of the percentage on the sum of the questionnaires. And you can see that the distraction level is low and the signal compliance level is high, as an attentive observer would do. For the lost in device waiters, the digital gamers, the usage of a mobile device is high, extremely high. The haste is not so high, but does exist. So that means that they're not too haste, because the time until the light is green for them is filled by using their mobile device. And that creates a risk. We identified a risk while these pedestrians will step from the curb into the road. Then we have the distracted law breakers, socially interacting on a high level, which give us the social risk profile. And these participants, this persona has an increased possibility to follow a lead pedestrian into the crosswalk just because they got it into their peripheral vision. And last, we have the anxious rusher with the highest possible level of haste, crossing the crosswalks, the streets in between traffic gaps. And we identified that these type of persons, the infrastructure, regardless of the infrastructure, they are quite resistant on different type of infrastructures, and keep that because the next slides, that will make sense. Now, as I said, we used the silhouette score to make sure that the K number, the K value 4 is the optimal. We ensured that, and then through the one-way ANOVA statistical test, these behavioral variables made sure that have a large or a medium effect on our sample, meaning that they reflect indeed the key feature of each one of the identified personas. So we were sure that we had the correct number of clusters / personas, and we identified correctly the key feature of each one of these personas. So now for the section A and the section B, two different types, let's say, of intersections in relation to having or not having a permitted or a protected phasing. The key findings were these. For the section A, permitted phasing, we had lower perceived safety ratings across all 4 clusters. We had a higher red light crossing rates across the full sample. And we had, for the flashing yellow arrows, a perception of reducing about the low breaker crossing by 4% versus the protected phasing, protected intersection. So for the next intersection with the protected phasing, we have a significantly fewer vehicle, pedestrian, and conflict points based on the design. Again, we have a red light for the vehicles, the green light at the same time for the pedestrians. We had a 13% increase in loss in device profile, as it's a paradox, but it's real, because when the participants felt safer because they are using an intersection with a protected phasing, they tend to use the device in a larger scale. And then for the axis rasters, we had they remained stable, and for that infrastructure, any changes about the infrastructure alone could be insufficient for this group. Then we try to find any possible measures or recommendations, and we came up with three of these mainly. The first one is about dynamic phasing for peak hours. We could change the section having a permitted phase into ones with a protected phasing just for the peak hours when, I mean, the students are walking into their classes or they're leaving their classes, and through the next time, the next time periods, we could have return back to permitted phasing. Another possible recommendation or measure or policy would be using multi-sensors for alerting the pedestrians or zombie lights. Imagine having a student watching his mobile device with a 45-degree angle. He won't see the red light. So if we had lights on the pavement or on the road, these students would identify based on the color of the traffic light, red or light, whether they could cross the street or not. And in fact, we have a cross section in Thessaloniki using this type of zombie lights, let's say. There are other, of course, European cities already using this type of lights. And then the most important as a policy or recommendation would be the V2X. I will start with the V2X communication, or where you can put as an X, V, the vehicles, vehicle to vehicle, vehicle to I infrastructure, and of course, vehicle to P communication, or as a P, we mean pedestrian. Imagine having a smart city, a smart infrastructure, informing a pedestrian walking near a crosswalk with a haptic interaction on his device that he's approaching crosswalk and must be alerted, must be cautious on how to cross the street. These are the three main policy recommendations coming from our side based on the collected data and their analysis. And of course, we have to keep in mind that none of these could be used horizontally. Each case is unique. We constantly say that when we talk about traffic and traffic studies. These could be implemented based on our case, but of course, adjustments could be made to be replicated. So we found out through our approach that the K-means clustering is indeed a methodology to be used to identify personas. We identified those 4 personas. We have a paradox about the loss in device, which means that at least with a protected phase intersection, when the pedestrians feel safe, intend to use their mobile devices more or discuss with a friend or a colleague. And of course, that just any intervention on the infrastructure would not ensure that we have the results that we want and we need. As for the future research, we're going to expand our sample to the general public. We have, let's say, we had our pilot through the students of the Aristotle University of Thessaloniki. And now, hopefully, in the future, we will be able to expand our sample and cover the general public and more in the section as well. That's all from my side. I can say I was on time. So thank you very much. And if you have any questions, I'd be happy to reply.
Thank you, Dr. Buras. Thank you for your interesting contribution. I want to underline the importance of this contribution, considering the extension of the university campus in the central to eastern part of the city of Thessaloniki, which is pretty huge, with a very big size of students population. So we are talking of about, I don't know, but the entire population, I mean, is around 90,000 people in the entire university. So we can understand the impacts in terms of road safety. Only this consideration from my side. So there are any questions from the audience, both from home and in presence? I think no questions for now. Someone in presence, I mean, I don't know if I don't see the screen from the in presence. There are any questions, communication, something? Because I think currently the camera for the profile room H is closed. So
I guess I explained everything very well.
yeah. So
thank you, Antonio.
If there are no questions, thank you, Dr. Buras, and we can move to the final presentation of this session 5E on the contribution from Elliot.
Yes, Antonio.
Yes. Can you hear me?
Yes, Antonio. Do you hear me?
Yes.
Do you see my presentation?
Yes, we can see from I can ask from. Yes, it is scrolling full screen. I want to ask, in presence, there is someone who is hearing us that can confirm that we are following us?
There are no people in presence, I think.
Okay. So we can move to the final presentation. The title of the final presentation is A Logical Framework Approach to the Monitoring of an Emergency Evacuation Exercise for an Urban Transport System. The authors are Corrado Rindone from University Mediterraneo of Reggio Calabria and me, Antonio Russo, and the presenter is Professor Corrado Rindone from University of Reggio Calabria. Thank you, Professor. The floor is yours.
Thank you, Antonio, for this presentation and for collaboration to prepare this work. The work is in the context of disaster risk reduction with a specific focus on the potential contribution of emergency evacuation exercise, and in particular with a focus in the role of the urban transport system. In particular, in this work, we try to propose a possible logical framework approach for monitoring the effect produced by a generic exercise, but in particular, in this case, for a training. The problem is underlined, but from this synthetical number that testifies the increasing number of disaster events and the projection in terms of economic losses. It is important to underline that the effects produced by disaster in recent years produce very important effects. There are, for instance, the number of displaced people due to conflict and disasters. And in this case, it's possible to see that the number is very important in the last years, the number related to the disasters. At international level, different recommendation of United Nations distinguish the two main moments of disaster event. The phases related to the preparation, then the all phases before a disaster event, and the phases related to the implementation of all action that are planned. That then it is important to understand the importance to move the problem from managing the disaster and then the consequence after a disaster to manage risk and safeguarding development. Then it is important in this context to have a good preparation, and this preparation is possible to reduce the gap between science and policy interface. In this work, we recall in particular the transport risk assessment and generic and consolidated analytical framework to represent in a quantitative way the risk. Risk has three main components: the occurrence, the vulnerability, and the exposure. And in this case, in our research, we focus the attention to the exposure. But working in exposure, it is important to underline the role of transport system in general to perform an effective and efficient evacuation procedures that can be analyzed and represented by consolidated models, transport system models that are used generally for ordinary conditions. Then, in this context, our research questions regards how is possible to bridge the gap between mitigation that regards in particular the evacuation planning and the response phases when it is necessary to implement the action planned in relation to evacuation and other emergency measures. The second question is regarding the possible measurement of capability of transport manager, and in particular, we want to verify if it is possible to verify the TSM knowledge after a training actions. Then this presentation is organized after this introduction in three sections. Each section try to respond to a specific research question. Then in the fifth section, we try to recall the main training and exercise actions. Then we present the proposed framework to monitoring the realization of specific training actions, and then a specific example. The presentation closes with a final section where the results of the obtained results are discussed with the conclusive remarks. The evacuation planning propose a set of material, immaterial, and managerial action, and it is possible to apply a set of transport system model to measure the effects produced by in the plan with the ex-ante evaluations. In this context, is possible in the context of immaterial actions, training and exercise plays a relevant role. In particular, we can have discussion-based activities that are low cost, aimed at reviewing or developing emergency plans and procedures. And other classes regards the operation-based, implementing in a real-world experimentation and testing the emergency procedures. Then from evacuation planning is possible to have the indication, but with the by implementing the training and exercise, it's possible to obtain a sort of monitoring data for improving the modeling. The final aim is for each generic action K, for instance, ASK, where S is a specific emergency scenario, to measure an exposure level before the implementation of the action K, and after this. This is a very general approach consolidated in literature, and we try in this work to obtain some measure of related to the effect of a specific actions. In particular, it's possible to recall in this case all possible discussion-based or operation-based according to the consolidated USA approach that classify all training actions, training and exercise action in relation to the an increasing level of complexity or planning and training, and an increasing level of capability of all participants in a training actions. Then, in our proposed framework, we try to measure this effect produced by a training action. And for this reason, we try to use the consolidated logical framework approach that is a results-based approach. This approach used in very different contexts. For instance, in the United States, this approach used for a specific law, or in Europe to be distributed to monitor structural fund. Then there are different agencies that develop guidelines for a single intervention. The main output of the logical framework approach is a specific logical framework matrix that can support the monitoring of the generic intervention with a synthetical representation of results. This approach is based to a specific problem tree. Then it's possible to have to observe the actions that create the problem, and then the consequence that is possible to control in terms of objectives or specific target. Then there is a sort of what if or causes effect approach. And in particular, it is necessary to distinguish the class of input that comprehend temporal, financial, and human resource that in this case are needed to implement a specific training and exercise actions. Then it's possible to organize a sort of exogenous activities related to the organization and implementation of the action. And then after these exogenous activities, it's possible to have the immediate product and concrete effect. This is the classical LFA approach that constitute the outputs, the immediate outputs. Then a sort of outcomes that in this case measure the capability level achieved by the participant, and final the possibility to use the capability in relation to the evacuation planning. There is an if-then logical that link the means then the resource to the ends by considering a set of external factors that lie and that link the resource to the final goals. In this case, we want to measure and to monitor the specific training and exercise action. It is necessary to introduce two new possible activities that in the classical approach are not included. The first class is the endogenous activities that link the outputs to the outcome. In particular, in this case, in this specific case, we want to measure the acquired knowledge about transport risk assessment and transport system models. And the second class of endogenous activities that measure the link from outcomes and goals. In particular, it is necessary to verify how the acquired TSM knowledge is applied by the participant. Then it's possible to have to introduce an analytical framework for each component. Then we have a set of indicators, for instance, for input in a generic way, that are collected in a specific vector of indicators, icon A. And then we have a set of functions for representing the exogenous activity, and then at the same time it's possible to have a vector, an output of output vectors. Then in terms of results, it's possible to have a set of functions for endogenous activities 1 and 2 in relation to measure the evolution from output to outcome and to outcome to goals. Then this is the logical framework metrics that allow the monitoring of all of a generic actions by distinguish all component of a specific action, and then the logical connection from the resource to the final results. We propose a very simple example of this approach, the proposed approach, and in particular, we think of a public entity, for instance, a region, that want to design and realize a specific training action for increasing from one side the capacity about evacuation planning, that there is the output, and then all the capability about how to do outdoor evacuation mobility that imply the knowledge of transport system models. At the end, we want to measure the performance in a discussion-based approach, the performance of the evacuation procedures that are the final goals of the procedures. In particular, we think that there is a possible an investment in terms of financial resources aimed at forming to train a specific set of managers. And then the exogenous activities regards the distribution for organizing and realizing the courses, the specific course, and then we can introduce a different threshold. For instance, in terms of number of hours that can are followed by the participant to the course. And we think that in this example that a percentage, a specific percentage of manager participate to and follow the all the hour in the course. Then it is possible to verify the acquisition of the capacity by a specific questionnaire, and in this case it's possible to measure introducing a specific quantitative threshold to for instance the minimum number of correct question to the questionnaire, and then it's possible to measure also the capability of manager to estimate the correct evacuation time by applying a specific set of TSM functions. Then we think, for instance, in this example, that as a subset of the initial number of manager, in this case, the 75% of the manager overcome the capability threshold. This is the logical framework matrix related to our example. And then with this logical framework matrix, it's possible to have some consideration, for instance, to have to quantify the monitoring effects of investment on training in terms of the output, for instance, because 90% of expected manager attend the course, in terms of outcome, because the 80% of manager acquired the capacity, and the final the goals by considering the part of manager that demonstrate their knowledge and their then capability to apply transport system models in order to reproduce and to simulate transport system in evacuation conditions. Then it's possible to close this presentation by underlining that disaster risk reduction is a very important global priority at the international level. And in this case, the training and exercise action play a relevant role in order to increase the preparedness level of people and manager. There are a set of guidelines, but focuses on primarily on capacity building. We try to, by using a logical framework approach, to support the monitoring of T&D actions, because this approach, in our opinion, increase the transparency in evaluation. Naturally, our work presents some limitation in relation to the specific class of action that in this case is a workshop. Also, the indicators and function are very limited, but exemplificative of our approach. And in the future, it is possible to have a general contribution by combining emerging ICT and transport system models in order to increase the performance and to increase the number of variables that can be monitored by in a specific action. Then it's possible to involve, for instance, the general public, or experiment other emergency scenario, or to follow the consolidated approach of serious games that are used in other contexts by using and by combining emerging ICT. Thank you for your attention, And okay, I finish here.
You, Professor Rindone. So there are any questions from who is connected online or from who is following in presence for Professor Corrado Rindone? I think no questions from no hand raised from online. Any questions from presence? No. Okay, so that was the last presentation. We ended exactly at the time scheduled by the conference, so 15 and 40 minutes of Western European times. I want to thank you all the relators for this session, Professor Rindone, Professor Fundas, Dr. Nicolaou, Dr. Buras, and Dr. Codroiu. I want to remind you that there is a second part of the Elliott workshop that will be tomorrow at 9 o'clock of Western European time. And I want to thank you, everyone. And for me, that's all. Thank you.
Thank you, Antonio, for all. Thank you.
Thank you.
Thank
Bye
you.
bye to all.
Bye, everyone.
Bye
Bye bye.
Hi. Am I audible? Uh, uh, cool. Shall I start?
You can switch to screen.
Yeah, I think my screen share is full.
Okay, so hopefully can you hear me? I'm Mark Fanfani. I will share this session, and I see that there is some changes in the program, so there's no problem for me. It's okay for all of us. And so we are all here. We can begin, and I think that we can start with. Okay. Marika, if I recall correctly, with the works on algebraic shift convolution networks for local to global semantic consistency in heterogeneous data graph. So you can share your screen and begin the presentation whenever you are ready.
Yeah, so I think I'm good to go.
Amit, okay, are you here? Okay, I didn't see you. Perfect, you can start. Amit, can you hear me?
Hi, can you hear me?
Yeah, we can hear you. So if you are ready, you can share your presentation.
Sounds good.
Can you hear me? Hello?
Yeah, I can hear you. There's a lag between the voices that I'm doing and from your side. So is it good now for everyone?
I didn't say yet the presentation.
Can you know?
Oh, okay, now, yes. Okay, perfect.
Perfect. Sounds good. Sounds good. Yeah, sounds good. Sure. Cool. So good evening, everyone. Thank you for being here for the session. And I'm sorry, there's some lag on voice. Yeah, I can. Yeah, I can hear you. There's some lag between the voice.
I didn't see any more the presentation.
Um, yeah. Sounds good. Sure. Yeah. So good evening, everyone. Thank you for taking your time for this session. I'm Amit from Docker and IT Bombay, India, and I'm presenting a joint work with Professor Nidhi Malik. So Professor is here. Just a quick hi, Professor Nidhi Malik from North Cap University, Gurugram, India. So Professor, just a quick hi.
Yeah, hi everyone. Thank you for your time.
Let me take over. We are here to present our paper titled Algebraic Sheaf Convolutional Networks. I call it as ASCN for local to global semantic consistency in heterogeneous graphs. So in the next 15 minutes, I'll try to cover three things. I'll try to explain why standard graph neural networks fail for real graphs and why our cellular sheaves fix this and what are our data perform on that. Yeah. So let me just quickly reiterate in a manner what we actually need in that method. Uh, so why homophoby breaks. So most of the graph neural networks that are there in the world, uh, is there some issue with my voice or on the screen? Uh, now voice back. There's some lag. I'm hearing my voice back. Professor Nidhi, if you can intervene.
Now it was, yeah, now it is clear, Amit.
Uh, but I'm still hearing it. Anyways, am I good now?
Yes, yes.
Cool. Cool. So, we don't assume these kind of things, but that's okay. That's technical glitch. Okay. Most of the graph neural networks that we say on a day-to-day basis, either that's graph convolution networks, GAT, there is an assumption corresponding to that, and the assumption is homophily. So the and connecting nodes tend to share labels. So let's put it that way. These kind of networks works well for social networks, but fails on biological systems, knowledge graphs, and other kind of real world graphs. I would say. Maybe the molecular formations. Uh, so just a moment. So let's put it that way. When we say in the heterophilic graphs, most edges connect different classes. So let's put it that way. If I'm talking about the Texas data set, only 11% of the nodes and the edges have the same classes of edges. Cornell shows 13%. Wisconsin shows nearly 20%. So I can say that 4 out of the 5 edges has different classes, and that is what we are discussing. We are not discussing about the homophily. GCN and GAT completely discuss that, and they actually solve that. But we're talking about the heterophily graphs and the heterogeneous graphs. So like if we go and do the symmetric averaging, that's called the over smoothing. But when someone comes up to me and say, can we use GAT instead, so I'll say like attention still lives in one shared space. So the goal is to learn the transformations, not just optimize the weights and just keep on optimizing the weights like we do in the graph attention networks or GCN. So the goal is to learn transformations, not just scalar weights, to align local coordinate systems before we start aggregating. So that was the motivation, and let's share our contribution to this. And the contribution is actually fourfold. The first contribution is ASCN. Like what ASCN is, it's a Shift Laplacian graph neural network that learns through restriction map instead of the scalar weights and directly from the nodes, and giving a algebraic coherency alignment to the heterogeneous graphs in local context, and that can scale up to the global context. The second step is cohomology as diagnostic. So we are using the sheaf cohomology groups. I'll explain the mathematics corresponding to that in a while, and then quantify logical inconsistencies and near-symbolic rule violations and a capability absent from heuristic GNNs. Third is we are using scalable node-based learner. That's the restriction map learning reduced from the OE to ON. O is and N is not MLP evaluations, and practically on larger graphs so that we can have a better computation power. And there's an extensive experimentation that we did on 5 heterophilic benchmarks, and beating GCN completely by over 36%, GAT by 33% on Winskin, and we are quite competitive to H2GC and LI and KX. So yeah, before I go into the bit of the theory, I'll try to explain where do this work fit. When we are talking about the ASCN, where does this fit? So we have 3 kind of architectures in the world. The first is the Euclidean space, where and the temporal space that we talk about the graph neural networks. Either that's GCN, either that's GAT, either that's graph OD. So the discrete, these kind of graphs use discrete masses passing in a flat space. So if I'm talking about a line, if I'm talking about a Manhattan space, if I'm talking about a Euclidean space, that's how these GCN, GAT, and other graphs work. And they are completely blind to the algebraic constraint of different relations. The other family belongs to the hyperbolic and Riemannian GNNs, and they are good for the hierarchical curvatures, but they are still distance driven. If I'm talking about the distance on a curve, so that's still distance driven, not coherence driven. And the third is sheaf and topological deep learning. That's where we stand. That's where Hansen and Gebhardt stand in 2020. That's where Border and the colleagues stand in 2022. So what we do is we assign vector space, which we call as stocks, and then the restriction operators to the vertices and the edges, and we call them as linear Laplacian maps. So we unify 4 gaps. So we identify a few gaps and we unify them, and that's where ASCN stands. The first is what Hansen and Gebhardt did. They didn't think about the relations as algebraic transformations. They were still thinking them as scalar weights. Second is coherence via spectral mechanism. Third, interpretable inconsistency measures. And fourth, subsumptions of KGE, the knowledge graph embeddings. So ASCN completely closes this graph. Now I'll actually make you dive into a bit of a theory, and then we'll discuss things. So the first question that comes up to our brain is what is cellular sheaf? A cellular sheaf is we can put it that way, like if we have a vertex, we have a edge. A cellular sheaf is just a function that we say, and the vertex space is called the vertex stock, the edge space is called the edge stock, and then there's a connection, the edge that we are having, and the connection between them, we call it as the linear restriction map, and that is defined by rho v restriction map E FV to FE. So the intuition is very simple. If V is a person and E is the relation born in or studies at, so the linear restriction map says how the embedding of the person V must be transformed to fit a birthplace context. So what a punchline can be something like edges are no longer just weight masses, they shape them. They are derived from the restriction maps. They are derived from the linearized maps. So let's start. Let's dive a bit into the theory again. when we talk about the edges, so let's put it that way. We call nodes as cochain space C0. We call edges as cochain space C1, and the co-boundary which defines the relation between the edges and the nodes, that is defined by the co-boundary, which is defined by delta x over the edge, and that is defined by the linear restriction map of the node to the linear restriction map of the edge, and that's the disagreement after projecting to the edge stock. And when we say delta x equal to 0, we are actually saying that that's a perfect local to global structure, and that's a perfectly consistent structure. And that's how we define, and we come and define the Laplacian, sheaf Laplacian. So a Laplacian of a sheaf f would be delta transpose delta, and that can be a semi-definite positive matrix whose values are always positive, and in our case the normalized values come into the range 0 to 2, and that's how we define the stable training. Okay, I think I'm good. Now let's just this is like when we are defining the Laplacian, we are actually defining the ASCN architecture, and ASCN architecture is nothing, it's just the diffusion based Laplacian. So when we say diffusion with learned restrictions, so sheaf diffusion evolves node features towards lower disagreement. So like the way we do the gradient descent, so it will actually resemble to you as some kind of a sequential or a graph Laplacian only. Okay, so let's put it that way. This is a sheaf learner module, this is a sheaf diffusion module, and we are actually at the end of the day just making a combination of a number of MLPs and the diffusion part, and just getting into a scenario where we say that each has its own row, the Laplacian map, and then we say that standard GCN is recovered as the trivial sheaf. ACN also subassumes the many KG schemes as choices of row. I'm so sorry. Yeah. Let's actually quickly go to the experimental setup as we are short of time. So we did it on 5 heterophilic data sets: Texas, Winskin, Cornell. Then from Wikipedia, Chameleon. Then actor occurrence, the data set was filmed. We choose a 60-20-20 train validation test split, 10 random seed, 4 trials reported. The stock dimension was 4, layers 2, shift type diagonal, diffusion alpha, that's 0.2, and the learning rate was 5 into testers per minus 4. The baselines were GCN, GAT, and the baselines for the heterophily was H2GCN and LinkX. So these were the results where we are actually winning. So the ASCN is the is our architecture, the purple one, and GCN and GAT are the homophily architectures. H2GCN and LinkX are the architectures which we are talking about, which are corresponding to the heterophily again. So ASCN completely dominates GC and GAT on every data set. It's competitive with heterophily specialized H2GCN and the LinkX best for Cornell data sets. Still, there's a difference between ASCN and the when we are talking about the heterophily and the homophily. So let's just discuss about the a few numbers we can see. It's completely beating GCN. It's nearly around H2GC and LinkX, and it's completely beating on the Cornell data set. So the test accuracy is calculated that way. So ASCN completely win outrights on Cornell within noise on Wisconsin, like some little noise, but completely winning with 25% and 36% above GCN and GAT on Texas and Wisconsin. Yeah, so the gains over baselines and the graph homophily are as defined in the, we are actually running so short of time, so I'll just be very quick on this. So the biggest gains land on the heterophily graphs, that's on Texas 11%, Cornell 13%, Winskin exactly where GCN and GAT fail hardest, and this is something I defined earlier. So again, yeah, one more thing that I would love to explain is going to be how smooth ASCN is with respect to the other data sets that we are talking about, whether that at H2GCN and LinkX. You just see the curve. The purple curve is for the ASCN. It's actually very smooth oscillation-free convergence because of the diffusion. The only perfect consequence of the principal diffusion mechanism that I discussed about shift diffusion layer. These are the sheaf energy and total variations that we discussed on different data sets. This one is the L2 norm, this one is the L1 norm, and L exploration, long-term decline, and yep. There was another one. So let's just quickly wrap up. So a few take-home messages would be SCN, that's a rigorous algebraic topological foundation for GNNs, replacing scalar weights with learned restriction maps. So if we are talking about GCN and GAT, it's completely like beating them from 7 to 36 precision. Competitive with H2GCN and LinkX on all 5 heterophilic benchmarks, uniquely offers cohomological diagnostics, provable spectral properties, and subassumes the graph Laplacian as a special case. So the future directions that we are thinking to work on, and if someone can come up and work on, there would be is conditions residual connection, because it's still there's a problem, which is the computability, how we can increase the computability. Low rank Paredes maps, relation type maps for cages, large stock dimensions. We took the small stock dimensions, very big graphs that we are talking about, pan 94, Twitch gamers, extended homology diagnostics corresponding to them. So these are the key references, and yeah. Thank you so much for there was a bit of technical glitch, but thank you so much for hearing me and hearing our paper. So yeah, I think I'm done from my side. Admin.
Thank you for your presentation. Very interesting. So if there is any question, there are any questions from the audience, please ask freely. There are no questions. I just a bit of curiosity. I was wondering how your filtering system can scale your restriction. Sorry, your restriction formula can scale on very huge graph. If you have some idea if this could be a bottleneck or can be handled in some way.
The actual answer corresponding to that is we are actually planning a follow-up paper and a follow-up research on this only, how we can scale it to a very large graph and do a very large computation corresponding to that.
Okay, so we are waiting for your next research then. Thank you. Okay, so we can move on to the next presenter. If I understand correctly, we have changed the program, so we move on Van Nguyen. Sorry if I spelled wrong.
Hello. I would like to know the author I have ever to switch presentations on. So I will present now, and author will present after my original note.
Okay, I think that you can start. You can share your screen and start your presentation whenever you want.
Yeah. Can you hear? Hello everyone, thank you for your time. I'm Nguyen from FPT University, and I decided to present a paper named the Learning Domain Space Embedding for Irreducible Argument Question Answering. That will focus on every question answering with reachable step in the system. The main idea is a generic embedding model might not understand every specific dragon well, so we Python domain-specific embedding model for irreducible outer funnel file main path, tutorial and motivation, cultivation, our main idea and derived method, then experiment and conclusion. Let's start with introduction. Today, every information is essential for evaluating certainty, involvement, and comprehension. However, it offers boring non-corporate report with technical network and structured data. Finding accuracy answer for a document is time-consuming and difficult. Therefore, automation in the question answering is important for providing reliable and verifiable results. About motivation, the Nanoweek model can answer many questions, but my hallucination went all alone. Rather reduce it by retrieving relevant pattern and using some art context. However, its effectiveness depends on retrieval quality. For embedding with an relevant evidence, it is especially critical in E3, where terms from GRE, SB, TCFD, and topic like carbon emission and governance are high specific. So without can every specific embedding improve retrieval for every question answering. Like a contribution, our have three main contribution will propose every rep domain specific embedding model for every retrieval argument question answering. Second, we derive with supervision pipeline to build chaining chipnet for suitability report using discussable content include from GRE, SASB, and TCFD. It allows us to create chaining data without manual pattern never annotated. Third, we evaluate every rep across segment by embedding backbone and integrate it into rack by QA system. Then we test the system across 14 LM and saw consistent improvement in downstream QA accuracy about 6%. Like the system overview. Here our pipeline of our approach. We start from corporate suitability report and funnel every reporting frameworks such as DA, SASB. For each report, we add the disclosure content index, the index map like a requirement to part where company record requirement, which has the disclosure requirement at query, then other revision about certain at positive pattern, and other certain from the same report at negative pattern. After that, we filter embedding model using conjective learning. Finally, the gender rep embedding model is inside the pipeline to retrieve better evidence for LM question answering. About data construction, the general model will need query and path of pair, but manually enabling every pattern is expensive because suitability report are long and technical. So we'll derive the twist step with supervision pipeline. Step 1 will extract query from the disclosure content index. For example, RAE disclosure required can become a natural language retrieval query. Step 2 we separate into chunks with 100 token overlap. Chunk from revision part become candidate positive pattern. Chunk from the same report but unrelated path become hard negative. In step 3, we use LM relevant gender to refine the label. Only candidate positive with sufficient syllable score are kept, and the process give us around more 100,000 high quality chaining chipnet for init point from 200,000 candidates. About evaluation data, we use for evaluation we use the ES new QA benchmark. The benchmark contain more than 1,000 expert validated multi-choice every question. The questions are grounded in irregular corpus which contain more 200 authoritative documents. They cover 7 source family. The benchmark is full spec from our training data, so reroute so whether every rep can generalize from corporate suitability report to a standard document, like our experiment, where main result for the embedding backbone. Now we can look at the main retrieval result, where find significant birth by backbone using conjecture learning with multiple negative ranking of the model learn to break a query crawl to a relevant pattern and fire from unrelated pattern across embedding backbone. It rep consistent improve query accuracy compared with the same pre-chain embedding without fine-tuning. On Arenda, the binary accuracy is 70.3%, while it rep like 77.5, giving average improve around 6%. Among all backbone model but by attributed by every rep accuracy with 78.5, followed by Fiber with 78.2%. The takeaway here is that domain-space fine-tuning have on every model reachable better every evidence, like a LM comparison in the query accuracy across 14 LM. The results so clearly improve for reachable state. The average result accuracy only around 65.9%, which beyond 35 reachable it improved to it improved to 69.7%, which generate then binary like more 17. Finally, with the area it average accuracy increased to 68. This means that the full area finite if total improve around 13.6 over the answer. The strongest LM also benefit from better reachable like GPT-5 partial like more than 19% when Gemini 3 like 18%. The key part is that even strong LM still near high quality reachable evidence. We also had adjusted as you can see in here. The hard negative sampling is very important where it was the pattern from same report to at chaining pair, and the query accuracy in a number of pattern for embedding is also very important. With the bed is three ritual pattern, it will return the best accuracy as you can see here from 1 and the bed E3. Even more retrieval pattern will make LM so down in all model. And then as a conversion. To conversion, we present a rep domain-specific embedding model for a reachable argument query with a scalable with supervised finite based on RIA-A, RISB, and TCFD disclosure to be chaining data without manual annotation. Experiments show improved query accuracy across multiple embedding model and LM, highlight the importance of strong retrieval. Limited includes the by word a array framework. The filter work will expand to multilingual data and are rerun and include more standard. over improved accuracy, reliability, and reactivity. Okay, that's all. Thank you for listening. I'm open for question now.
Thank you. Thank you for your presentation. And there is any question from the audience? No question. So just to see that you have stated that in the future work you want to extend on more standards. And in your opinion, is this something that will require a huge work or your model can be adapted pretty easily?
Because our current pipeline is only focused to three framework. As you can see, sorry. With me. You can see our pipeline is focused only to three framework area. The ISAB and TCFD. So our framework này will give our accuracy. Our framework này EPC and CBD will return now accuracy. I will check it.
Yes. Okay, let's move on. If there are no other questions, I think that we can move on the next presenter. So the next one should be Daniel Martins. Will present class-specific potential weighting query strategy for online active learning in intrusion detection. So you can share your presentation and start the talk. Thank you.
Hi, thank you. Good afternoon, everyone. My name is Daniel Martins, and today I present our work entitled Class-Specific Filter Weighting Query Strategy for Online Active Learning Intrusion Detection. This work is part of my PhD in Rio de Janeiro, Brazil. Here is my email address in case anyone would like to discuss this work later. So let's begin. To motivate this work, let me start with some important facts. Network intrusion detection systems, or NIDS, are essential cybersecurity tools. They monitor network traffic and help protect critical infrastructures and organizational assets. However, modern network environments are constantly evolving. New applications appear, traffic patterns evolve, and attackers continually develop new attack techniques. As a consequence, maintaining detection performance becomes very challenging. Models gradually become outdated because the data distribution changes over time. At the same time, obtaining labels from cybersecurity experts is expensive and slow. Therefore, we need methods that can continuously adapt intrusion detection models while minimizing the amount of human labeling. This brings us to our research problem. Now, considering these dynamic environments, we ask the following question. How can we improve sample selection in online active learning to efficiently adapt multi-class intrusion detection models while minimizing labeling effort in evolving network environments? In other words, since human experts label some samples, how can we improve the selection of the most useful ones? Our work here makes three main contributions. First, we propose a class-specific feature weighting. The main idea is to learn feature relevance independently for each attack class, because different attacks exhibit different characteristics. Second, we propose a weighted feature representation. Suspicious samples are projected into weighted feature space that emphasize the most discriminative features during the query selection. Finally, we integrate this knowledge into a hybrid OAR strategy, online active learning strategy. The objective is not only to select informative samples, but also to improve the separation between known attacks and new attacks. Ultimately, our objective is to achieve better online active learning performance under limited labeling budgets. Now let's talk about the core idea of this work. Traditional feature weighting is global. The methods usually assume that all classes share the same feature importance. In other words, they assign one global relevance score to each feature. However, attack classes exhibit heterogeneous behavior. Different attacks generate different traffic patterns. For example, for those attacks, traffic volume attributes can be very important. Other example, infiltration attacks, protocol information and packet size may be more relevant. When we use global feature relevance, important information can be diluted. Features that are very formative for minority class can be overlooked. To address this limitation, we propose CSFWOS, class-specific feature weighting for OpenSet. The framework estimates feature importance separately for each class. As a result, we can capture attack-specific characters that are ignored by global approaches. This is our core idea. Before I present our method, it is useful to understand where it fits within the literature. This table compiles the main active learning strategies that have been applied to intrusion detection. The first group includes traditional methods such as uncertainty sampling, query by committee, and density-based approaches. There is traditional strategies. Also, if these methods use different query criteria, they all share one important characteristic. They rely on a global view of the feature space. All of them is a global view of the feature space. More recent methods have started to incorporate feature information directly into the query process. For example, AEL-FIL uses feature perturbation based in relief functions, and ShapeAL uses model explanation to guide sample selection. These methods represent an important step forward because they recognize that feature relevance matters. Our framework is model agnostic. This means that it can work with different feature importance estimation methods with multiple implementations. For example, we can use input-based importance which measures how much a feature reduces input in tree-based models, such as decision tree or random forest. All of these are based in a one-best-all approach. We can also use shape values, which measure the contribution of each feature to an individual prediction. Although shape is widely used for explainability, it can also be used to estimate class-specific feature relevance or feature importance. Finally, we can use relief F functions, which estimate feature importance by evaluating how well features distinguish neighboring instances from different classes. But the most important point here is that our framework is flexible and independent of a specific feature weighting method. It is model agnostic. After estimating class-specific feature importance, we need to decide how to apply these weights to the samples. Our proposal is not simple about selecting or removing attributes. Instead, we transform the samples into a weighted feature space. We investigate three strategies. The first one, probability-weighted feature space. In this approach, we combine all specific class weights according to the posterior probabilities of the models to construct 8 vectors. Therefore, classes with higher confidence have a stronger influence, while less probably classes still contribute to the final representation. The second approach is the most probably class weighting. Here, we simply select this class with the highest probability and use only its feature importance. The third approach is to top K class average weighting. Instead of considering all classes or only one class, we average the H vectors of the K most probable classes. This strategy represents a middle ground between the two previous methods. Of course, there are only examples. These are only examples. Many other weighting strategies are possible. For instance, we could combine only the class whose probabilities are above a predefined threshold. Before I present our method, it is important to position it within the active learning literature. This figure shows a general taxonomy of query strategies. Pay attention to these two left blocks. The first group is representativeness-based strategies. These methods select samples according to their distribution in the feature space. Examples include density-based and clustering-based approaches. The second group is informativeness-based. These are the most traditional approaches the most used approach today, especially uncertainty sampling. They select samples located in difficult decision regions where the model is uncertain. More recently, research have started combining both ideas, creating what is called hybrid strategies. In the next slide, I will show how our proposal fits into this category. Here, I'll summarize our online active learning loop. A new batch of traffic arrives. The model makes your precisions. Suspicious samples are identified. These samples are projected in the class-specific age filter space. Then, our hybrid query strategy selects the most representative and informative instance for XPath labeling, for human XPath labeling. Finally, the model is updated with the new labels, and the process repeats continually. Our contribution is concentrated in steps 4 and 5. We cluster suspicious samples in the weighted filter space and select the cluster centroids. After, we use the remaining labeling budget to select formative instance using margin sampling. To evaluate our proposal, we perform experiments using two benchmark datasets, CICE-EDS 2017 and NF-UNSW NB15V2 to simulate real-world stream conditions. The data stream is constructed such that the initial training set includes only benign traffic in a single kernel attack class. The remaining attack class are introduced progressively over time. The initial training contains 1,000 samples. Each additional batch has, the initial training has 10,000 samples, and the next batch has 1,000 samples. We use random forest as a classifier model, mini batch k-means for clustering, query ratios for 1, 5, 10, and 20%. For this study, we are using gene purge for filter importance estimation and probability H filter space as the 18 strategy, as we defined before. Finally, use a frequential evaluation protocol, meaning that each sample is first tested and then used for training. This table presents the average performance of 10 runs on CICE-IDS 2017 dataset, show our results. We compare our approach against three baseline strategies. The first one is random sampling. The second is uncertainty sampling using margin sampling. The third is a hybrid strategy, similar to our proposal, but not use class-specific filter weighting. This comparison allows us to isolate the contribution of our proposed AT mechanic. Overall, we observe modest but constant gains. Our approach gets best improvements at query ratios of 1% and 10% in this data set. And on the other, the best gains occur at 10%. This indicates that class-specific attenuation improves the efficiency of the sample selection process. Now, this figure shows the evolution of the micro F1 score. The dotted vertical lines indicate the moments when new attack classes are introduced into the stream. At these points, we observe a temporary performance drop. This behavior is expected because the model finds attacks that it has never been before. However, after new samples are labeled, the performance recover. This recovery demonstrates that the proposed strategy is able to identify informative samples and learn emergency attack class effectively. Now, per class analysis. We can see that the performance of emergent class improves over time. Some attacks are learned very quickly as fuses, while others improve more gradually as generic. Minority classes usually show high variability, example, backdoor, and those attacks do not achieve a higher FU score. This behavior highlights the heterogeneous of attack class intrusion detection problems. In general, we have similar patterns in all experiments. From these experiments, we can make several observations. First, class-specific attenuation improves sample selection because it captures attack-specific characteristics that are ignored by global weight methods. Second, we obtain positive results in open set swing scenarios. The results indicate improved learning efficiency. The method adapts effectively to evolve traffic and frequently shows fast recovery after the introduction of new attack classes. Finally, our framework is practical and scalable. It is modular, model agnostic, introduces only a limited additional computational cost per batch. In conclusion, the relevance of class-specific tools can improve online active learning, both labeling efficiency and adaptation to emerging class. As future work, we intend to integrate full open set and incremental capabilities, explore other hybrid strategies configurations, robustness to adversarial attacks, use label propagation and adaptive budgets. Thank you for your attention. That's all.
Thank you, Daniel. Nice presentation. And I ask the audience if there is any question about. Please talk. If you have questions. just one curiosity, maybe I didn't get correctly, but I was curious, your framework learn class-specific way to identify attacks. So I was wondering if there is new attack, zero-day attacks, it can be quickly adapted to them, or it needs some time. Maybe I missed something, I don't know. Can you hear me?
Oh, the core idea is the specific attack class are specific features importance. So with this strategy, we can efficiently separate the no attacks and separated in a feature space 18. In the new attacks, as the feature character is different, the separated will be more visible. Are you understand?
Yeah, okay. Okay, thank you. So let's move on the next presentation, if there are no questions. So we can leave the stage to Alexander Kolchin for presenting the paper, a formal constraint-based method for detecting gaps in input validation test suites.
Hello everyone, my name is Alexander. Me and my colleague from the Institute of Cybernetics, Kiev, Ukraine. Our work is about improving the reliability of software systems. It mainly focuses on testing and static analysis. The proposed method helps to systematically find gaps in existing test suites related to input validation logic. So we will talk about input validation related problems, about existing approaches and test coverage, and also motivational examples. Afterwards, I will present the method description and conclude. Reliable input data validation is the basis of secure software. External data is considered untrusted because it comes from unreliable sources. It can be caused by user mistakes or even by attacks from malicious users. Therefore, before using such data, we need to carefully check it, or say validate it. The result is either valid and verified data or proper error handling. If the validation is done incorrectly, untrusted data can reach vulnerable parts of the program and lead to unwanted consequences such as crashes, incorrect calculations, or even cybersecurity problems. Thus, thorough input validation is an essential defense of the system. Numerous studies, including the Common Weakness Enumeration (CVE) rankings, identify weak or inconsistent input validation as one of the most frequent sources of software vulnerabilities and functional errors. And despite its critical role, it is still difficult to systematically assess how adequate the, and I would say, achieved input validation testing is actually. So, is our test suite adequate? Although numerous structural coverage criteria exist in software testing, they generally do not specifically target the completeness or inconsistencies of input validation itself. And there are many different coverage criteria: data flow, modified condition decision, requirements-based testing, and also testers often use equivalence class testing. This approach partitions the input domain into subsets that are expected to produce similar behavior and then selects representative test cases. However, such partitions rely on assumptions made by the tester and may not reflect the actual validation logic implemented in the code. As a result, some validation conditions can be overlooked, which leading to incomplete coverage. And to show the limitations of traditional coverage criteria in assessing input validation completeness, we consider two small programs together with their test suite. In both cases, standard structural criteria can be fully satisfied, but some constrained regions, let's say sync locations, are still not exercised. This means that parts of the effective input domain, namely those that affect observable behavior, may remain uncovered. For this program, on the left, we can see three test cases, and this test suite fully satisfies all uses criterion, modified condition decision criteria, and the others probably. Well, it's easy to check. From the data flow coverage perspective, we can see that all definition use pairs for the variable res are covered. So here we have value 1 assigned here. Here we have value 10 assigned at line 7, and the last test case again value 10, which comes from this restriction actually. Well, so from the equivalence class testing perspective, the value of variable x falls into the following classes. X less than 1, it's verified by test number 1. X is more than 10, you can see it here in test number 2, and X is between 1 and 10, test number 3, but well, one may assume that the intended range of acceptable values of res at line 11 is therefore from 1 to 10. Note that this test triggered a call to the function process for only two input values, 1 and 10, and all other possible ranges, including x less than 1 and more than 10, remain untested, even though they could be exercised by inputs of the form, say, x, any but not 10, and v should be false. So we will go around these conditions and result in actually any value except 10, right? So this naturally raises the question of whether this situation reflects merely missing tests or whether it exposes a defect in the program's validation logic. Note that our method doesn't attempt to decide the program correctness, nor does it explicitly identify single specific critical values. Rather, it identifies potential input ranges at relevant sync locations that are not covered by the existing tests, thereby guiding the developers for further inspection. For the next example, you can see here similar situation. We have three tests. This test suite fully satisfies MCDC and all uses criteria. However, none of these tests exercises the case in which the value of variable d passed as an argument to function div, so that this value lies in range less or equal to 0. Because in this case n is 0, and we will not go to line number 5. Well, note that assuming div performs an arithmetic division, 0 value could result in a runtime failure due to division by 0. This problem could be easily detected in modern static analyzers if the value will be used explicitly in the denominator. But in the case of our example, it is not explicit, it is, let's say, veiled. So this just to summarize the problems. So input validation is critical, and modern, say, approaches rely on testing using structural coverage criteria, but the structural coverage criteria is not specifically targeted on value ranges at sync locations, and it can therefore miss some defects. And the main idea of our work is based on the observation that the effect of input validation depends on how the program later uses the validated data. Therefore, equivalence class testing can be applied more precisely at sync locations, where the input affects external actions or other critical operations. This slide illustrates that although the validation procedure itself is covered, it's very primitive here, less than 10 or more or equal than 10, so both cases are covered, right? The values used at sync locations may remain untested. So we have the sync location here is this call to function send, and you can see that there is a path where variable x can be redefined, and thus this range, namely more or equals than 10, may remain uncovered by this test suite. So this test case should be added, right? In order to cover this range also. So building on this insight, we automate the detection of input validation gaps by analyzing existing tests in terms of symbolic constraints derived from the code. For specified input variables, we track constraints as they propagate towards sync locations, thereby capturing how validation rules influence observable behavior. And we then interpret these constraints as equivalence classes represented in the current test suite and use them to identify missing tests. So the key idea is simple. If a potential test would produce weaker constraints at sync location than any existing test, this suggests a path where validation check may be missing. This approach provides a systematic way to assess and improve the completeness of input validation. To formalize our approach, we present the program as a control flow graph. For every input, the program follows one execution path. We call this sequence of executed statements by test case as a concrete trace, and then we build an abstract trace. It follows the same path as a concrete one, but replaces actual values with symbolic expressions. For each program, program location on the path, we compute symbolic constraints on the input variables. Intuitively, they describe which input values are still possible after all validation checks performed along that execution path. Now we can define when an existing test suite is incomplete. If there exists another feasible execution path, whose constraints at the selected sync location are not covered by the constraints of any existing test, then the current test suite is incomplete. In other words, the program contains a validation scenario that has never been exercised by the existing tests. Such path becomes a candidate for generating a new test case. In similar way, we detect ranges, overlapping ranges, to produce new boundaries to be covered. And this slide shows the connection of the symbolic constraints at sync locations with equivalence classes over the input space. For deterministic programs, every additional validation check can only reduce the set of possible input values. Therefore, If the constraints of a new path are not covered by any existing path, then the corresponding set is the corresponding set of valid inputs is also different from all previous input sets. And this means that we refine equivalence classes of inputs. This slide presents a high-level overview of our approach for analyzing an existing test suite and generating new test cases. First, I would like to emphasize that the new test cases are generated as an extension of the existing test suite, rather than from scratch. The process consists of 4 main steps. First, we perform symbolic execution of the existing test suite for each test case. And then, if a value range is not covered by the current tests, we generate a new test objective to cover that range. If different test cases cover overlapping value ranges, we generate additional boundary test cases for each overlap. This slide illustrates how the method will derive new test objective from the example number 1. In blue box, you can see the concrete trace traversed by a test case with these concrete inputs. X is 0 and V is false. And green box represents an abstract trace that is corresponding to the control flow of this concrete test. And we can see that the restriction at the sink location is as follows: res is not equal to 10. And on the red box illustrates the constraints which corresponds to the test case number 1. And we can see that the constraints of new test case are not subsumed by the constraints of existing test. And in that way, comparing with all other tests, we can conclude that the test X any but 10 and V is false is missed. So this is the, let's say, algorithm of new test cases generation. This slide summarizes some limitations of current prototype. So it's about complex data structures like pointers, strings, and together with loops. We deal with loops like bounded model checking. We can consider a certain number of iterations. Actually, we need only the first time sync location is observed on the trace. And all those sync locations currently are specified manually. And this slide briefly concludes. So structural coverage alone is not sufficient to ensure input validation testing. And our preliminary experimental results show about 15% increase in both the number of tests and the mutation score. Of course, this is only a preliminary evaluation. Our future work will focus on addressing the current limitations and validating the approach on real-world projects. Thank you for your attention. That's all.
Thank you for your presentation. And there are any questions from the audience? Okay, just curiosity, if I understand correctly, at the moment, the method cannot scale on commercial complex production software. Is correct?
Yeah, it's just a prototype on 2 examples right now, so it's planned for the future.
Okay, and this limitation is more related to computational complexity, or inherently by the model itself that is not able to explore all the.
There are a lot of sources of limitations, right? Starting from complicated language constructions and on theoretic level, solvers and provers land in the symbolic executions, and but still, nevertheless, we can deal with formal models, and probably as a starting point, it still will be interesting to experiment.
Thank you. Thank you. And we can move on our final presentation. I think Arthur Nunes is online. And please share your screen for presenting Horizon Aware Feature Selection and Evolutionary Optimization of Intraday Prediction in Future Markets. Please, the stage is yours.
Hello, can you hear me?
Yep.
Can you see the screen?
Yeah, perfectly. Go right. Perfect. No, perfect is when you go full screen is I see captured the presentation.
Wait. Just a moment.
Oh, okay, perfect.
Okay. So, hello everyone. My name is Arthur, and today I will present our work entitled Horizontal Aware Feature Selection and Evolutionary Optimization for Intraday Prediction in Futures Markets. This work was developed in collaboration between the Federal University of Rio Grande, São Paulo State University, and the University of Rio Verde. So first, I will briefly introduce the motivation and objectives of the work. Then I will present the proposed methodology, including the feature selection and optimization procedures. Finally, I will discuss the experimental results and the main conclusions obtained from this study. So, starting with the motivation, financial markets are highly noisy and non-stationary environments, especially in intraday scenarios. Price movements change rapidly over time, making short-term prediction extremely challenging. In addition, intraday environments are strongly affected by volatility, market microstructure effects, and rapid behavioral changes. These characteristics make predictive modeling substantially harder when compared to longer-term forecasting tasks. Another important issue is the high dimensionality of financial datasets. As the number of features increases, machine learning models become more sensitive to pre-processing and redundant information, which may negatively affect generalization performance. Additionally, feature relevance may vary depending on the forecasting horizon. In other words, a feature subset that performs well for short-term prediction may not necessarily generalize well to longer horizons. These challenges motivated the development of a horizontal-aware prediction workflow. So, the main objective of this work was to propose and explore a horizontal-aware workflow for intraday financial prediction. More specifically, we applied sequential forward selection using different estimators, optimized multiple classifiers using genetic algorithms, and analyzed predictive performance across multiple forecasting horizons. The evaluated classifiers were multi-layer perceptron, random forest, and k-nearest neighbors. The main idea was to investigate how forecasting horizons influence feature relevance and predictive behavior. So now I will present the methodology. This slide summarizes the complete workflow adopted in this study. First, the market data was pre-processed and transformed into technical indicators. Next, forecasting horizons were defined and sequential forward selection was applied. After feature selection, genetic algorithms were used to optimize the hyperparameters of each classifier. And then finally, the optimized models were evaluated using macro F1 score. So, macro F1 score was selected because it evaluates both classes independently and avoids performance being dominated by a single class. This is particularly important because in our problem, identifying both upward and downtrend market movements is equally relevant. The entire workflow was designed to investigate how forecasting horizons affect both feature relevance and predictive performance. So, the experiments were conducted using the BOVDB version 2 dataset. We focused on the Brazilian wind futures markets using 5-minute candlesticks data collected between January and June of 2024. The dataset contains approximately 15,000 instances. We evaluated 3 forecasting horizons. FH equals 1 represents short-term prediction. FH equals 5 represents a mid-range horizon, and FH equals 7 represents a more extended prediction horizon. The purpose of evaluating multiple horizons was to investigate how predictive information behaves over time. Short horizons may preserve stronger local market structure, while longer horizons tend to accumulate more uncertainty and noise. The prediction task was formulated as a binary classification problem. Class 0 represents downtrend movements, while class 1 represents uptrend movements. The evaluated classifiers were multi-layer perceptron, random forest, and k-nearest neighbors, as said before. These models were selected because they represent different machine learning paradigms. MLP represents a neural network approach, random forest is an ensemble-based method, and KNN is an instance-based learning algorithm. For hyperparameter optimization, we employed genetic algorithms using a population of 15 individuals, 1,000 generations, and a crossover probability of 0.8. To represent market behavior, we generated 42 engineered features based on technical indicators. These indicators include trend-based measures such as simple moving averages, exponential moving averages, and others. We also included momentum-based indicators such as MACD, ROC, and others too. Before training the models, the data was normalized, standardized, and rescaled according to the pre-processing requirements of each indicator. For feature selection, we employed sequential forward selection. Importantly, the selection process was performed independently for each forecasting horizon. This allowed the workflow to adapt feature subsets according to different temporal dynamics. As we will see in the results section, different horizons produced substantially different feature subsets. And then now, I will present the experimental results. So, this slide presents the feature selection behavior when KNN was used as the sequential forward selector estimator. For the short-term horizon, the model retained a larger number of features and achieved the highest macro F1 score. However, As the forecasting horizon increased, the selected subsets became substantially smaller. This suggests that only a limited number of indicators remained useful for longer prediction horizons. Another important observation is that predictive performance consistently decreased as the temporal horizon increased. This behavior indicates that predictive signals gradually weaken over time in intraday financial markets. So here we observe the feature selection behavior using random forest this time as the estimator. Unlike KNN, random forest retained broader feature subsets across all forecasting horizons. And this behavior is likely related to the ensemble structure of random forest, which can better handle high-dimensional feature spaces and nonlinear interactions. Even though larger subsets were retained, we still observe performance degradation for longer horizons. This reinforces the idea that predictive signals gradually weaken over time in intraday financial markets. This slide compares both estimators, KNN and random forest, under the longest forecasting horizon, FHA at FH equals 7, the prediction task becomes substantially more difficult. KNN selected only a very compact subset of features, while random forest still retained a larger feature space. Overall, the results indicate that feature relevance is strongly dependent on the forecasting horizon. In other words, there is no universally optimal feature subset across different temporal horizons. Features that are relevant for short-term prediction may lose predictive importance as the temporal horizon changes. So, this table summarizes the feature selection results for KNNs as an estimator. The number of selected features decreased significantly for longer horizons. For random forest, broader feature subsets were preserved across all horizons. The best feature selection performance was obtained for FH equals 1. Overall, the results suggest that forecasting horizon has a strong impact on both predictive performance and feature stability. This slide presents the final performance results for the multi-layer perceptron. Although genetic algorithms improve some configurations, the MLP did not consistently outperform the simpler classifiers. Performance decreased substantially for longer forecasting horizons, and we also observed that feature subsets generated using random forest as the sequential forward selector estimator produced more stable results. One possible explanation is that the selected subsets may have favored KNN and random forest during the classification stage. An important observation is that increasing model complexity did not necessarily improve predictive performance under the evaluated setup. Feature quality and forecasting horizon appear to play a more significant role in this problem. This slide presents the final results for random forest KNN. Random forest achieved competitive and relatively stable performance across all horizons. KNN achieved the best overall macro F1 score, particularly for FH equals 1. However, both models also experienced performance degradation as the forecasting horizon increased. Overall, the results suggest that forecasting horizon and feature selection strategy had a stronger impact on predictive performance than model complexity itself. The results also reinforce the importance of horizontal modeling strategies for intraday financial prediction. So, in conclusion, the experimental results showed that predictive performance was strongly influenced by forecasting horizon. Short-term horizons produced better classification results, while longer horizons became progressively more difficult to model. We also observed that feature relevance changes across forecasting horizons, indicating that horizontal-aware feature selection is an important aspect of intraday prediction. Random forest and KNN achieved competitive and consistent performance while increasing model complexity did not necessarily improve predictive quality. Overall, this study highlights the importance of horizontal modeling strategies in intraday financial forecasting. The results suggest that forecasting horizon may influence predictive behavior more strongly than model complexity itself. For future work, we intend to investigate alternative feature selection strategies, modern deep learning architectures, and real-world trading evaluation. And thank you very much for your attention, and I will be happy to answer any questions.
Thank you, Arthur. And if there are any questions, please ask. Just a single question from my side, and I was curious if you have thought about in a real financial scenario, the genetic algorithm that you use to optimize the upper parameter of your method, how frequently should we rerun to re-optimize the upper parameter? Have you some idea about
how? Sorry, I didn't hear everything. Can you repeat?
Sorry. No, I was talking about the genetic algorithm that you use to optimize the hyperparameter of your method. In a real scenario, you think should be rerun frequently to re-optimize the weights since the market change regime very quickly usually?
I think we have more modern approaches, but only with testing we can determine this. So, as I said in future works, I pretend to use other metrics such as Sharp Radio and other models too that are more modern and more used as well, because these are classic models.
Okay. If there are no other questions, I suppose we can close this session. I thank you all the speakers for the interesting presentation, and we can hope you can continue to follow the conference from remotely where you are. And thank you all, and goodbye.
Thank you.
Have a nice day.
Thank you. Goodbye.